Today, we're diving into a guide for a new era of software development called Compositional Software Design for agentic systems. It really gets to the heart of a huge challenge we're all facing. As AI systems get more and more complex, how do we make sure we can still trust them, audit them, and, actually verify that they're doing what we think they're doing? So let's break down its approach.
Here's how we're going to walk through it. First, we'll look at the book's main purpose. Then, we'll cover who this is really for. After that, we'll unpack its core three-part structure, touch on a few key concepts, and then finish up with the practical skills you can expect to gain.
All right, so let's start with the big why. What is the fundamental problem that this guide is really trying to solve?
At its heart, it's all about this idea of compositional design. You know how it is, as we weave more AI into our software, these systems can quickly become black boxes. This guide offers a practical, engineering-focused method for designing them in a way that keeps them verifiable and auditable. It's really all about maintaining control and understanding, even as the complexity skyrockets.
Okay, next up, who is this actually for? Let's figure out if this is the right kind of material for you and your team.
This guide is really aimed at experienced technical leaders. We're talking about the people making the high-level design decisions, folks like software architects, staff engineers, tech leads, and platform engineers. Basically, if you're building AI products and need to balance that formal engineering rigor with the reality of shipping software, this is for you.
Now, in terms of what you need to know coming in, a solid background in software architecture and design is definitely required. But here's the important part. You do not need to be an expert in category theory. The book uses concepts from it, sure, but they're treated as helpful context, not as a barrier. That makes the whole thing much more accessible.
So how is all this information organized? Well, the book lays everything out as a pretty logical three-part journey. It all kicks off with the absolute foundations, defining those critical responsibility boundaries between humans and AI. From there, Part 2 digs into how you can translate between different models and integrate components without breaking the whole structure. And finally, Part 3 brings it all home, focusing on coordination and how you actually deliver a complete verifiable system. It's a clear path from start to finish. Now, along this path, you're going to run into some formal-sounding concepts, but they're always presented as practical engineering tools. Let's just briefly touch on one key idea from each of the three parts to see how they build on one another. Everything begins with composition. This is really about using a clear visual language. Think objects and arrows or boxes and lines to model your system. By creating a precise blueprint right from the get-go, you establish clear boundaries and verifiable structures. This clarity is the foundation for everything that comes next. So once you have these cleanly defined parts, you need a reliable way to connect them. That's where functors come in. A good way to think of a functor is as a kind of safe translator. It lets you map one part of your system to another, like a domain model to a database schema, while guaranteeing that the core structure is preserved. It's how you build up a complex system from simple, verifiable pieces without things getting out of control. Okay, so your system is defined, it's integrated, but how does it actually interact with the real world? This is the challenge that Part 3 tackles with monads. In engineering terms, a monad is just a pattern for handling effects. Things like database calls or API requests. It lets you draw a very sharp line between your pure, easily testable logic and all the messy, unpredictable interactions, which is crucial for keeping the core of your system verifiable.
All right, so after working through all these concepts and structures, what are the practical skills you'll actually walk away with? What's the payoff?
Here's what you'll be able to do. You'll learn how to define really clear, unambiguous boundaries between human review and AI workflows. You'll be able to model entire systems with precise diagrams, use formal patterns for robust integration, and probably most importantly, you'll see how to translate all this theory into a concrete, auditable engineering workflow that your team can actually use every day. And that brings us to the final and maybe most important question that this guide encourages you to ask. As AI becomes less of a tool and more of a collaborator, defining its role and our own is one of the most critical design decisions we can make. So the real question is, how will you draw that line?